Hi students, we're going to be working on derivatives, and what we're going to first of all practice is using the power rule for derivatives. Let's use this example of finding the derivative of f of x equals 17x to the 10th plus 13x to the 8th minus 1.8x plus 1003. So the rule we're going to use is called the power rule. And here's how it looks. So the basic form of the power rule, d dx of x to the n power, is going to be n times x to the n minus 1. So to find the derivative of this function, we'll take 17, and then we're going to multiply it by the exponent, or by the power. Like right here it says in the power rule, the exponent was 10. And then x to the 10 minus 1. Let's go ahead and simplify that term right now. 17 times 10 is 170, x to the 9th. These will start to become very easy for you. You can almost do them in your sleep. That's how easy they'll become. So for the second term here, 13x to the 8th, to take the derivative, we'll take the 13 and then multiply that by the power that we're bringing down, which is 8, and then x to the 8 minus 1. So this will be 104 x to the 7th. And then the next term, negative 1.8x, will be negative 1.8, the derivative. And then we're going to multiply it by the exponent, which is on the x. And don't forget, there's a 1 there. Any term, any variable that has just an x is x to the first. So we'll multiply that by 1, and then it'll be x to the 1 minus 0 power. So 1.8 times 1 is 1.8. X to the 0, by definition, is equal to 1. So that'll be just multiplied by 1, and that will be 1.8. And then 1003, the derivative of a constant is 0. So because of that, then the 1003 just drops off. So if we take off this 1, then since it was just 1.8 times 1, our answer for our first derivative here of this function is 170 x to the 9th plus 104 x to the 7th minus 1.8. Let's now find the derivative of this function. F of t equals 3 times the square root of t minus 4 divided by t to the 4th. So let's rewrite this so that it's in a little easier form for us to take the derivative. And what I mean by that is we're going to take 3 and then a square root of anything, I'll just call it t since that's what we're using here, is going to be the same thing as t to the 1/2 power. The rational exponent or power here represents the square root function. So this will be 3t to the 1/2. And then also this term here, 4 divided by t to the 4th. When we have 1 over t to the 4th, we can represent it as t to the negative 4th. So using our negative exponent rule here, whenever we have a term that's in the denominator, right, like this one is of the fraction, we can move it up to the numerator but put a negative exponent on it. So this would be 4, if it's 4 divided by t to the 4th, this would be 4 times t to the negative 4. All right, and let's take the derivative now of this function here. It's a little bit simpler form. We'll use the power rule again because we just have individual polynomial terms. So we'll take the 3 and we'll multiply it by 1/2. And then the variable will become t to the 1/2 minus 1. Remember, with the power rule, we are always subtracting 1 from that power or exponent. Minus 4, and then times the negative 4, t to the negative 4 minus 1. Let's simplify a little bit. 3 times 1/2, you could think of this 3 as 3 over 1. So we can just multiply across. 3 times 1 is 3. 1 times 2 is 2. And then we'll have times t. 1/2 minus 1 is the same thing as 1/2 minus 2/2, because 1 can be expressed as 2 over 2, which would be a negative 1/2, which will be our exponent here, or our power. And then we have negative 4 times negative 4 is positive 16. And then we have negative 4 minus 1, so the exponent or the power on t is going to be negative 5. We don't generally want to show exponents with a negative exponent in your answer, your final answer. So what I want to do now is, because I have here t to the negative 1/2, using our negative exponent rule in reverse, I can think of it as 1 over t to the 1/2. All right? So which means I would have 3 over 2, and then the 2 would be multiplied by t to the 1/2, because once again, what happened? That part, that variable factor with the negative 1/2 power comes to the denominator and has a positive exponent on it. Plus 16, the same thing here. We have t to the negative 5, which is going to be 1 over t to the 5th. All right? So we'll be multiplying the 16 times 1 over t to the 5th. 16 times 1 is 16, divided by t to the 5th. And this is the best form. It's the very nice form of our final answer for this problem. One thing you're going to find when you're working on calculus derivatives is that the derivative may not be so hard to find, but it's really the simplification that can get a little tricky sometimes. But this is the best form of what you're going to do for this problem. So again, this is not in final form, again, because of these negative exponents. So we need to resolve that, which we did. Another format that this could be written in, and probably a preferred one by some textbooks, because notice the very beginning, we started with a square root. So we might want to show this final answer like this. 3 divided by 2 times the square root of t plus 16 over t to the 5th. Personally, I would accept either answer, but the rule in mathematics is when we simplify, we really want to go back to what we started with, the type of expressions we were given. So if that's the case, which is truly what we see here, we would want to express that variable in a square root. We're going to now work a problem that's a little bit different than what we've been doing, which has been just to find the derivative of the function. It's going to look different, this problem, but it's actually, we're going to be doing the same thing along with something a little extra. So we want to find the equation of the line tangent to g of t equals 10 minus t squared, where t equals 2. So remember, the derivative is the equation of the line tangent to the function. What's interesting about it is we could have a function that looks like this. I'm just going to draw something kind of random. And wherever we are on the graph, if we're there, or we're here, or we're here, we are finding through the derivative the equation of the line tangent to that function anywhere on the graph. So let's take the first derivative. So g prime of t, the derivative of 10 is 0. Derivative of any constant is 0. And then we'll have that negative sign because it's attached to the term that follows that sign. Yes, it looks like a subtraction, but I could also write this as 10 plus a negative t squared to make it clearer that that negative sign belongs with the term. Using the power rule over here, the power rule will bring down the 2, and then that 2 on the exponent will subtract 1, like we do in our power rule, and it would just become t to the first. By convention, we don't normally write t to the first. We would just write a t here. So our first derivative is negative 2t. That is the equation of the slope of the tangent line. Now what we want to find is what's the actual slope of that tangent line when t is equal to 2. So I'm going to replace t here with 2 in our derivative function. So we'll have negative 2 times 2, which is negative 4. So that is the slope of the tangent line when t equals 2, the line that's tangent to our function. Now the slope, but we didn't yet find the equation. So the equation that we would be looking for is y equals mx plus b. No matter what my function looks like, if it's a quadratic or a cubic or a quartic or something higher in degree, we'll always have a tangent line. So the tangent line will have this form of y equals mx plus b. So what we found so far is m, but we don't know b, and we need to find it. So what would we do? We need to find an xy ordered pair that's on the line. We're given a hint. We're given that t is 2. So if I take my original function and evaluate it at 2, so 10 minus 2 squared, or 10 minus 4, which is 6, that means that the ordered pair 2, 6 is on the graph of g of t equals 10 minus t squared. So it's a point on the graph, and it's what we needed here to find our b, or our y-intercept of that line. So let's go ahead and plug in our xy ordered pair that we now know. And y is 6, and x is 2. And now I can solve for b. I only have one variable. So I'll have 6 plus 8 is equal to b, or b is 14. So therefore, our equation of that tangent line at t equals 2 is going to be y equals negative 4x plus 14. Bye.